welcome to today's edition of GT Maths. We'll be looking at factorization, and here we define factorization as a way of writing an expression as a product of its factor. Now we're just going to take some examples. If for instance I ask you to write 10 as a product of its factor, here we go. 10 can be written as the product of 2 and 5. So you have just expressed 10 as a product of its factor, which in other words means you've just factorized 10 into factors. So the same goes for algebra. You could actually factorize an algebraic expression. Let's say for example you are given 3x to factorize. This can go as 3 and as x. So 3 times x will give you 3x. So expressing it in its factor is what you call factorization. You can have a single term also that you wish to factor. Say for example you have 15x squared. Now we can factor 15x squared. We can break it down to 3x and 5x. It can be in any form. It can be this way also. 3 bracket 5 bracket x square, depends on how you want to split it, and you can have it as 3 bracket 5 bracket x and bracket x. It all depends on the number of factors you're looking at. Here we're looking at just 2 factors and 3 factors and 4 factors, as the case may be. So let's go into factorization proper. The first step here is factorization of linear algebra, which of course is called the polynomial. That is actually going to be our area of emphasis, and there are a couple of steps we have to follow to be able to do this properly. The first step here says to identify the HCF of the linear algebra. You identify the HCF of the linear algebra. By now you should know what a linear algebra means. We discussed that in our previous classes. And the second step here is to divide the HCF out of every term of the linear algebra or polynomial. Now we're just taking an example here. It says factorize 4y raised to power 5 minus 4y raised to power 3 plus 2y. The way it's done normally, you say what's common between this? Yeah, that's the right word. What is common between all the terms? Now this is a single term. You have to look at them individually. Let me use a highlighter. This is a single term, this is a single term, and this is a single term. You have 3 terms in all of this. So you have to look for what is common between them, and not just what is common, the highest common factor. That is why I said factor out the HCF, the highest common factor between them. Now if you look at what is common, 2 is common here, 2 is here, 2 can go into this, 2 can go into this, and 2 can go into this. 2 is common. As a matter of fact, you have 2 can go into this, and you have 2 can go into this as well. But y also can go. Y can go into this, y can go into this, y can go into this. So 2 and y can go, and 2y also can go. So among these 3 things that can go, you have 2, you have y, you have 2y. Which of them is the highest factor in all of this? It's 2y. So you first of all identify the highest common factor and factorize it out. So we are going to do this quickly. Our solution here becomes what I was able to identify and factor out is 2y. So I have 2y. If 2y goes into 4y raised to power 5, what will be left? You have 2y raised to power 4. Then if it goes into minus this, you have minus 2y raised to power 2. And if it goes into this, you have plus 1. Remember, if 2y goes into 2y, you're going to have 1, not 0. And the sign is very important. You take note of the sign as well. So this is what you're having as your final answer. If there is any other thing that can factor out, you factor again. But if there is none, you leave this way. So this is what we are having for this answer. Now we'll take some more examples. Here you say factorize 3x minus 6ax plus 12a. Now let's see what is common between them. 3 can go into this, 3 can go into this. Sorry, I have to use an highlighter so that I don't get you confused. Okay, 3 can go into this. You have 3, 3 can go into this. Yeah, sure, 3 can go into this, sure. And what else can go into? There's nothing else that can go into, so 3 is the only thing that can go into them, so that becomes our highest common factor. And if I'm going to solve that, I'm going to have 3 into, and you factorize it out according to the second step. 3 goes out into this, you have x left. 3 goes out into this, you're going to have minus 2ax left. And 3 goes out into this, you're going to have plus 4a left. So this is your final answer. Since there's nothing else that can go into it, you leave your answer this way. So this is the answer for number 2. And number 3, let's see what the solution would be. Here we have to find out what can go into. By looking at this, 5 can go here, 5 can go here. You have 5 out. Okay, 5 is one of the factor. P square can go into this, so we have p square and p square. So 5p square is the highest common factor that can go out. And what I'm going to have is solution here. I have 5p square. If it goes out of this, you have 5p. Okay, just 5 left, because the p square is actually going out. The 5 from this 25 is going out. You have just 5 left. Minus, you bring down the sign because this one carries the sign and nothing temper with the sign. 5 goes out of 10, you have 2, then just 1p left in this case. So this is what you're getting as your final answer for this very one. The fourth example here, wow, this is a little different from the first one. Here we have something in common, but the thing in common is a binomial. It's not just a single term, it's a binomial. So I will quickly highlight this. This is common here and it's common here. You can see it's already in brackets, so you can just pull it out. So you have 3x minus 1 out, and you also have 3x minus 1 out. So there's a common binomial between these two. And when I pull out the common binomial, according to my factorization, it's anything that is common, you pull it out. It is the highest common factor because that's the only thing that can go out. Assuming there is another thing here in the coefficient that can go out, fine, you pull it as well. But in this case, we'll take it out. So we have 3 as solution becomes 3x minus 1. That goes out. Now if it goes out of this whole expression here, you have just x left, and if it goes out of this expression, you have just plus 5 left. So when you pull out this binomial, you find out that it's giving you 2 separate binomial in all. So this is very important because this is the very first thing you need to know in solving factorization proper. Now we'll move to the next step here, and the next step here says factoring a polynomial with 4 terms by grouping. Previously we've been treating 2 terms, 3 terms. The highest we've done is 3 terms, I guess. Yeah, these 3 terms. You have term 1, term 2, and term 3. There are 3 terms we've been treating. Let's see the other one. Okay, this one is also 3 terms. You have 1, 2, and 3. The moment you get to 4 terms, in fact even number terms, when it's 4, 6, as the case may be, you group them because it's actually too much. You can't just start solving one after another like that. You can't just pull something out. You have to group them. I think it will be very, very cool. So whenever you have 4 terms and above, always group them. So in this case we are going to group, and according to the steps here, it says what you do for the first step is to group the first 2 terms together and then the last 2 terms together. So the first step is to group these 2 together, which I'm actually going to do here like this. Wow, that's cool. And the last 2 terms, wow, that's great. So we are looking at these 2 terms in this way. And the second step says factor out the highest common factor of each separate binomial. So we're working on this, we'll work on this, whatever we get, we'll factor it out. We'll work on this, whatever we get, we'll factor it out. So that's exactly what we're going to be doing. And that's what the second step says. And the third term says factor out the common binomial. So whatever we get, we're going to factor it just the same way we did this one. This was a case of factoring out a common binomial because you have a common binomial here. This is a common binomial, so this and this are common binomial. So what this saying is we may have something that look like this and we'll just factor it out. Now let's go ahead to see what this will give. If I'm taking the solution to this, it will be the first step. I have to group them, and here I'm going to do that. I have 7x raised to power 3 minus 14x raised to power 2. They are all grouped by a single line. Okay, now minus x plus 2 is also grouped by a single line. So what we're going to do here is this, applying the second step that says factor each of the binomials separately. So we're going to look at this. What is the common term here? What is the highest common factor between these two? You have 7x. It can go into any of these two. Now by now we should know how to do this very fast. And this will be x left. Whenever it goes out of this, you have x left. When it goes out of minus 4x squared, sorry, 7x squared is even a factor, yeah, because you have x squared here and here you have x cubed, and this is just single x left. And you have 7x squared goes out of this, you just have minus 2 left. All right, sure. And this other case, let's see what we're going to have here. Whenever you have a minus x plus 2, and what I want to achieve is something that will have x minus 2, which means for me to have x, I have to take minus 1 out. So I'll have minus 1 out of this, I'll have x left. Now minus 1, when it goes out of plus 2, you have minus 2. How? It's simple. Whenever I take a minus sign out, the sign that is inside, that's this very sign inside, will change. Take note of that. And if you look at it, if I'm going to expand this again, minus 1 times minus 2 will give me plus 2. I'm getting this very one back. So I think you should take note of this very one anytime you are factoring out a negative sign. The sign inside will definitely change. So this becomes step 3 says factor out the common binomial. So this is a common binomial. You have this binomial common with this, so we're going to factor that out again, and what we'll get is x minus 2 goes out of the whole term here, and I'm having what's left when x minus 2 goes out of this. You have 7x squared and minus 1 left. Remember, anytime you factor a thing out, the remaining are kept in a bracket. So that's why we're putting this one in a bracket. So this is a product of 2 brackets, and that's the end of your factorization here. Okay, the second example here says it's a 4-term polynomial. Sure, we can group them in 2. We already know what to do when we have 4-term or 6-term or 8-term. As soon as it's an even number, we should know what to do. So we'll group these 2 and group these 2, and when I factor out this, I'm going to have x squared out, so x squared goes out, and I'll be left with just x plus 3. And this other one, I have 2 out, plus 2 goes out. I'll be left with x plus 3 as well. So x plus 3 is a common binomial here. I pull it out. Now I'm going to have x plus 3 goes out, and whatever is left will be inside another bracket, which is x squared plus 2. So my final answer is this, which is the binomial. So just take note of that. We're going to be looking at more of factorization. Today we'll be looking at factoring a trinomial of the form ax squared plus bx plus c. And if you look very closely at this trinomial, a trinomial means a 3-term expression. So you have term 1, which is this over here, term 2, and term 3. This reminds you of a quadratic expression. So this is a quadratic equation. This term is a quadratic equation, and as a matter of fact, we'll be looking at how to factorize a quadratic equation. We have a couple of steps here that we have to follow. The first step says factor out a GCF from each separate term, if any. Now, the first thing you do when you are factorizing any expression in the form of polynomials, as a polynomial expression, what you do is to figure out if there is a GCF. If there is, you factor that out. That's the very first thing you do for every polynomial that you have to factorize, whether linear, whether quadratic, whether polynomial of higher degrees and all that. So what's a GCF? Yeah, GCF means HCF. We discussed that in our previous class. And what that simply means is that we have to find if there is a common factor here. And the factor is, it doesn't just have to be a common factor, it has to be the highest common factor. That's exactly what we're talking about. So step 2 here says find the two factors that their products equals the product of A and C. So what you do is first and foremost you multiply A and C. This is what you do for the very next thing. Second step will be to multiply A and C. So you're now going to find two factors that their product will give you the product of what you get from A and C, and their sum equals B. So the very first thing you do when you are going to solve for a polynomial expression of this kind, multiply A. Once you are not able to identify the common GCF, you can just go ahead to multiply A and C. Whatever you get, think of two numbers that their product will give you the outcome of A and C, and their sum will give you B. So this is going to be what you're thinking of. You have to take a very good note here. As you are finding these factors, you have to consider the sign of the expression of your outcome, A and C, and also the sign of B. Now look at what you do. If AC is positive, if whatever you get from multiplying A and C is positive, your factors will both have the same sign depending on the sign of B. And if the outcome of AC is negative, your factors are going to have opposite signs depending on the sign of B also. You take a note at that. We'll see more of it in the examples we'll be looking at. Then we'll go to step 3, which says substitute substitute the sum of your factors in step 2 for the value of B to generate a 4-term expression. So whatever we get in step 2, we're going to substitute the sum of the values for B, and that will lead us to a 4-term expression. And remember, we discussed factoring a 4-term expression in our last lessons, and it says just continue factoring the 4-term expression by grouping. So once you can identify the 4-term expression, you just continue to factor it by grouping. Now we're going to look at a couple of examples here. The first example says ax squared minus 5a minus 14. Now first step, if we apply the first step here, we'll find out there is no GCF. There is no highest common factor. There is no common factor between these terms. So my a here is 1. Remember, the a refers to the coefficient of your first term with a square power, and here it is imaginarily taken as 1, although it's not written, but we know that this is the same as saying 1a. So it's like 1 times a, but that doesn't mean. We'll go to step 2, which says multiply a and b. So we're looking for, a and c. We're looking for a times c, and in this case it is 1 times minus 14, and that will give us minus 14 also. And it says find two terms that their sum will equal b, and here we have b to be minus 5. So this is what we're doing. These are the two things we are looking for. The terms that their sum would be equal minus 5 and their product will be minus 14. Now let's think. If I think of 7 times 2, as a matter of fact, it's giving me 14. Then 7 plus 2 is giving me 9, not 5. So that's actually wrong. But I can manipulate this sign to get my value. Minus 7 times 2 will give me minus 14, which is what I have here. And that's correct for what I want. Then minus 7 also plus 2 will give me minus 5. That's also correct for what I want. So minus 7 and plus 2 are the two terms. So I'll just go over to plug in those terms in the value of b in my expression. So let me quickly take this off so that I can have space to solve. You already know how I was able to generate that now. And okay, here we go. Now I'm going to put those values into b according to step 3, and this is what I'll get. Becomes a square. In place of b, we'll have minus 7 plus 2. That's what they said. And all value of a. This whole thing now, what is taking my place of b now, minus 14. And that's going to be like a square. Now minus 7 in bracket minus 7 plus 2 will be plus 2. You have two signs here that you have to resolve into one, and you have plus 2 or bracket a minus 14. Now this a is going to multiply everything out in the bracket, so I'm going to have a square minus 7a, okay, a square minus 7a plus 2a, okay, minus 14, okay. So this is now a 4-term expression. I remember whenever you're solving 4-term expression, you group them in 2. That's what step 4 says. I can group these 2 and these 2, and if I'm working on these 2 first, this is what I'm going to get. What is common between these two terms here? I have a common, I take it out, and what's left will be in a bracket, so I have a minus 7 in a bracket. Now look at the second term here, which is the next thing I'm going to solve. I think of what's common between these two. I have plus 2 as a common term. Then if it goes out of this, I have a minus 7 left. So now I'm having two other expressions with a common binomial. So I have this whole expression and this whole expression with a common binomial. So I can factor out the common binomial according to what we have been doing about 4-term expression. And this is just going to give me, let me take this value down here. I have a bracket a minus 7, then plus 2 brackets a minus 7. I'm going to factor out a minus 7 out, so I'll have a minus 7 goes out of the first term. Whatever I have is going to be in a bracket, so a is left there. It goes out of the second term, plus 2 is left there. So here I'm going to have a minus 7. This is my final answer, a plus 2. It has been factored to the product of two factors. Remember, factorization has to do with expressing terms in product of its factors, and that is exactly what I have for that solution. So I'll go over to the next one here that says factorize the expression 2s squared y plus 6sy plus 30y, that's 30y. First is to think. First step, is there a GCF among these terms? Is there a common GCF here that I have to factor out? Yeah. Here you have 2y, here you have 2y, and here you have 2y. It can go into any of these terms. So it's a common GCF here that you need to factor out. And when you do that, you're going to get 2y goes out. So whatever is left will be in a bracket. X raised to power 2 That's when it comes out of this, you have x raised to the power 2 left. Then plus, when 2y goes out of 16x y, you have 8x left. And bring your plus sign. When it goes out of 30, you have just 15 left. So this is exactly what I'm having, and that will become remember, my 2y is there. What I'm actually going to solve here is this quadratic expression, because we're not done yet. This is a quadratic expression that needs to be factored further. So I'll use my quadratic method. Here I don't have any I don't have a GCF anymore, so I'll just go using step 2, and that's the value of a here is 1. So I think of two numbers. If I take a times c, that will be 1 times 15. 15 is a plus sign, and that will be equal to 15 as well. And my b has a value of plus 8. So I'll think of two numbers that I'll add will give me plus 8. When I multiply, I'll get 15, and that number would be 3 and 5. 3 times 5 is 15. 3 plus 5 is 8. So I'll put them in place of 8, and I'm going to have let me be very fast about this. I'm going to have x square plus 5x plus 3x, because you have plus 5 plus 3, and when they multiply this x, you're going to have 5x plus 3x plus 15. Now I'm generating a 4-term equation, because this actually is taking the place of this. So 4-term expression that I need to factor using method of grouping, which the fourth step says. So I'll group these two, and I'll group this other two, and what I'm going to have, remember, my 2y is still there outside the brackets. I'm actually solving everything inside brackets, so I have what's common between here. X is common, then it goes out, and you have x plus 5 left. Then what's common between here, plus 3 is common, it goes out, you have x plus 5 left. So this whole thing will be in a bracket here, and let's see, this can be solved further. I'll have 2y, sorry, I think I really have to work on this page very well. And I'll have 2y all in a bracket. Now let's see, here you have two terms with a common binomial. You have this term and this term, but they have a common binomial, which is x plus 5, x plus 5. So x plus 5 is going to go out here now, and I'll have x plus 5 coming out. Okay, then whatever I have will be left in a bracket. Whatever is left is going to be in a bracket. So I have, if it goes out of this, I have x, and if it goes out of this, I have plus 3. So this is what I have inside the bracket now, and what that means is that I'm having 2y all in a bracket, x plus 5, x plus 3. Now I can remove this big bracket, because everything here has been factorized in a product form. So it's like saying 2y times everything in the bracket, and this can be expressed as 2y, okay, because whenever you bring 2y and you attach it to this whole thing, it becomes x plus 5, x plus 3. Either case, they are multiplying themselves out, so this is my final answer. And I can take more examples here. Here it says factorize the quadratic expression. The first step still would be to find the GCF, and to me, I don't see any GCF here. I'll just go starting from step 2. Let me identify my a here is 3, my c here is 2, then a times c will be 3 times 2, and that is 6. My b here is plus 5, and I'm going to look for two terms that their product will be 6 and their sum will be plus 5, and they're going to take the place of b here. So I'm going to have new equation as 3x squared. Now those values will be 5 and 1 times, that's 5 times 1, no, 6 times 1. Let's see. 6 times 1 is 6. 6 plus 1 is 7. What about 2 and 3? 3 times 2 is 6, and 3 plus 2 is 5. So 3 and 2 are the two right values. So I'll just take them here and I'll have plus 3x plus 2x. Remember the sign is very important. Then you now have plus 2 here at the end of the day, because what you're doing is that you're only substituting the values here, the sum of the values, which is this, in place of this. It still did not change the original equation. The original equation still comes in. Now it's just that you're able to make this a 4-term expression, and I'll quickly do this. So here I can write it again as 3x squared plus 3x plus 2x plus 2. Now I have a 4-term expression. The next thing I'll do is to factor it by grouping. I'll pick this 2 and I'll pick this 2. And here I'm going to have what's common between these two. 3x is common, so I factor it out. 3x, whatever is left within the bracket, which is x plus 1. Because when 3x goes out of this, you have x. When it goes out of plus 3x, you have 1 just left. Now let's see what's common between these two. You have plus 2 common, so I'll take plus 2. When it goes out of 2x, you have x left. Then when it goes out of plus 2, you have plus 1 also left. And here again, 2 terms with binomial expression in them, and the binomial expression can be factored out as a matter of fact. So that becomes x, this is what I'm having now, plus 1 goes out of these 2 terms. I'll have just 3x left here, then plus 2. So this is my final answer for that expression. This is what you do when you do your factorization. Let's see, there's another question here. It says the expression 5x squared minus 18x minus 8. Quickly, I'll just identify my a here is 5, my c here is minus 8, then a times c is 5 times minus 8, and that will be equal to minus 40. Then my b here is minus 18. Wow, these are quite big numbers, but let's see. What are the two values that I'll multiply to get minus 40, and when I add them I'll get minus 18? Let me think. What about 20 times 2? You can see that 20 times 2 is really a good one there, but it depends on how you want your value. If your product here is minus, so your answers will have two negative values, so one will have a positive and the other negative. But if I give 20 the negative, so that it will influence my answer here, because 20 and plus 2. Now let's see that 20 and plus 2 are the two values. 20 and plus 2. Now let me see if they are correct. If I multiply these two values, am I getting minus 40? Yes, I am. If I add these two values, am I getting minus 18? Yes, I am. You can actually check that out on your notes, and you see what I'm talking about. So they will take the place of minus 18, and I'm having this value as the new value as 5x squared minus 20x plus 2x minus 8. So they've actually taken the place of minus 18 here, and I'm going to solve for that by grouping, and I'll zone out this 2 and this 2. Let's see what I'll have. What's common between these two here? 5x is common, so when it goes out, I'm having 5x factoring out, and I'll have x minus 4 left here, because when 5x goes out of this, you have x. When it goes out of this, you have 4. Please always take note of that. Then what's common between these two is 2, and I have let's see, plus 2 goes out here, you have x minus 4 still. So x minus 4 is a common term again in the next expression that we just generated, and I'm looking at these two and these two. There are two terms, but here you have a binomial and here you have a binomial, and that can be factored out, and my overall answer would be x minus 4 coming out of this term. Now you have 5x, remember whatever is left will be in a bracket, then if it goes out of this, plus 2. So that is exactly what you're having. So this is actually giving you x minus 4 5x plus 2. That's our final answer. So you can pick as much exercise in your textbooks and solve as much as you can. Meanwhile, there is what you call the prime trinomial. There are some quadratic expression that cannot be factored. It's not in all cases that you can factor out a quadratic expression, but first and foremost, you have to make sure that it cannot be factored before you declare it a prime trinomial. Let's say, for example, you have x squared plus 5x plus 12. Let's see. The first step will be our a is equal to 1, our c is equal to 12, and our b is equal to 5. Now ac, that's a times c, will be 1 times 12, and that is 12. And let me think of two values that will give me, when I multiply them I'll get 12, and when I add them I'll get 5. Now just try and keep thinking. 2 times 6 is 12, but 2 plus 6 will not give you 5 in either way, whether you take negative sign for 2, negative sign for 6, whichever way form you take it. Now another factor of 12, again another factor that we could possibly think of is 4 and 3. 4 times 3 will still not, will give you 12, but if you add them they will not give you 5. Another possible factor is 1 times 12. Now just try and think and think and think. You'll find out when you keep thinking you're actually not going to get anything, so you can now declare it as a prime trinomial. Remember the definition for prime numbers: numbers that can be divided by only one and itself. That's a condition. So this is also a prime trinomial. It does not have other factors. It is only one and itself. So in this case, this cannot be factored. If you are asked to factorize, you cannot factor out this expression. So that is what we're going to stop for today. Here we'll be looking at factoring a perfect square trinomial. The first thing you need to know is that it has to be exactly in this form to use this rule. Okay, when you have a base being squared plus or minus twice the product of the two base plus another base squared. Now look at this. What do we refer to as the base here? This is the base, and this is a base also. So you have a base being squared plus 2. Why is the base? The base here is a, so twice the base and the product of another base, okay, and plus the other base being squared. It is being factored as a, that's the first base plus the second base, all squared. That is why it is called a perfect square. A perfect square means the both base has a perfect square. So you can have it this form, or you have it as the base minus. So the difference here is just when you have the 2 plus 2ab first plus 2ab, or you have minus 2ab. So that's where the difference actually lies. And what you do is whenever you have a plus 2ab, you are having a plus sign between a and b, and whenever you have a minus 2ab, you have a minus sign between a and b. Take note. First, make sure the expression, the trinomial expression, can be expressed in this form before you can actually factorize like this. So you have to take a very close look at this. Make sure you understand this very, very well. Please look at it very well, and we'll be looking at examples. The first one says factorize the perfect square trinomial. Although in this case I stated it that it was a perfect square trinomial because it actually can be expressed in a perfect square, but there are some cases where they don't state it. So we're going to look at how this would be solved here. We'll take a look at our solution. Y square plus y square plus the product of this will be 2 brackets. Y can be expressed here. The base here is y. Then the product of this very one is 7 plus 7 square, because 7 square will give you 47. So if you once you're able to express it in this form, it's then is a perfect square. So you have y square plus 2y7, which is the base here, plus 7 squared. Look at it, it's compared to a square plus 2ab plus b square. That was our expression. So you can actually look at the comparison. Let's see it again in the expression here. It says a square plus 2ab plus b square. So that's exactly what we have been able to establish in this second case. We've been able to express it in this form, where your a here is y, your 2y, then your b here is 7, and here is expressed also as 7. So this can be factored as a plus b all square. So this would be y plus 7 all square. So as a matter of fact, this very solution would be y minus 7, sorry, plus 7 all squared. So this is what we are having as our factored form. You remember that this is the same as y plus 7 or brackets y minus, sorry, plus 7. Plus 7 is multiplying itself twice. If you don't actually know how to use this, you can also use the same quadratic method we did before. You get the same answer. You can try it out. Just play with all of these things and you get what we're talking about. Now look at this other one here. It says 9x squared minus 30xy plus 25y squared. Well, this very case we'll have our solution as I want the whole of this base to have a common square, because I don't, there's no coefficient. According to my formula, you have a square plus or minus, but in this case we're having a minus here, so we are looking at the one with the minus sign. So I'll just take this plus out and indicate a minus sign. 2ab plus b square. You can see that this base does not have a coefficient. It does not have a coefficient, and this does not have a coefficient as well. So we're going to make sure this coefficient is also expressed as a power. So that will become 3 raised to power 2 x raised to power 2. Now this is what we are having, minus 2 brackets. If you break 30 down, what will you get? That should be 2 times 15, but we need something like 2 times 5. Okay, remember the base, the whole of the base here, although we'll come to that. Let's see. Let me first of all just indicate this very one now. Once I'm able to establish the base, I'll take that out. Minus 30xy plus, now this one can be broken down to 5 square. So 5 square y square. Now this one has 3 square x square. I can give out the square to both of them. I can take a common square, becomes 3x all square. This now becomes a base minus, now if I break this one down, let me see if I'll get it. 2 times the base here, which is 3x and the base here is this is supposed to be 5y all square. Remember, both of them have common base. Now if I break this other one down, the base here will be 5y, so bracket 5y. I will probably check this out if it will give me my answer. Let me write this out very well. So I have 3x all square minus 2 brackets 3x bracket 5y plus 5y all square. Let me actually see if this very center point, let me work on this. This has already been expressed in a base. 2 times 3x will be 6x. 6x times 5y will be 30xy, which actually is correct. So this will be, remember it has a negative sign, you now have the perfect square base, which is 3x minus 5y all square. So this is my final answer for what I am supposed to have. You can compare this to the formula there and you find out it's the same thing. So as a matter of fact, let me quickly just state this very well. What I'm having from this end here is 3x minus 5y all square, so which is the same as this very one here. The next thing we'll be looking at is the factoring a difference of 2 square. The difference of 2 square, x has a square here, minus a has a square. Difference means minus, so difference of 2 square, the square of this and the square of this. So difference of 2 square can be factored to be the sum of the base brackets the difference of the base. Now the moment you can identify an expression in this form, it becomes the sum of the base and the difference of the base. This is actually what they call a conjugate. This is the conjugate of x and a. So we'll be looking at that later, and we'll see all that also in irrational numbers. In fact, we saw that in irrational numbers. Now look at this. Sum of 2 squares cannot be factored. This is a note for you to take. Do not factor sum of 2 squares. So if you have s squared plus a square, it cannot be factored. That's why you see this is not an equal to of dash dash dash. So no matter what, you're still going to get your answer and it cannot be factored. Okay. Here it says factor the expression y squared minus 16. The moment we can express it in the difference of 2 square, bam, we have our answer. Here will be the solution to this will be y square minus 16 can be represented as 4 square. Now this is the difference of 2 square, right? And that becomes y minus or y plus 4, whichever one, you can take any one first arbitrarily, y minus 4. So the sum of first base, second base, and the difference of second base, first base, second base. Take note, you have to take this first before this. So this comes first. Do not mix it around. Okay. We might want to look at some other examples. Say factorize the expression. Well, this whole thing, the square here is applied to x alone, but we can actually make it have a common base by expressing this one as a square also. So we can say a solution to this can be 5 square, okay, x square minus, this can be expressed as 9 square. You know 9 square is 81, so this becomes 5x with a common square minus 9 square. And the moment you can express this as this is a difference of 2 square. Remember, you have single base here, and this will become 5x plus 9, then in another bracket 5x minus 9. Well, I can take this out like let me write it out here very well. 5x plus 9 in the brackets 5x minus 9. So this is what you call the difference of two square. The moment you can identify this part as a single base square and this part as a single base square with a different sign, you can actually factorize. We want to give you a couple of assignments to do. This is y raised to the power of 4 minus 16. Actually, I want you to apply everything you've been taught to solve this very one. Although you think I've not taught you raised to the power of 4, but it can be solved using one of these methods that we have studied. So factorize y squared minus 16 completely. You have to factorize it completely, so it's the underlining word, completely. Alright, take a look at this very well. Factorize 27a squared plus 36a plus 12 completely, and the third one says factorize 6x squared minus 17x plus 5 completely. So make sure you are able to do this out, and the moment you can solve this, then you are good to go with any aspect of factorization that relates to the difference of two square, perfect square trinomial, trinomial factorization, which is required to factorization, and factorization of linear expression, which we